Well, welcome back to Wickerson Studios. I may actually be on to something with this series. I actually have this in ray trace, so it's going to take a little bit to process, but you can see how that one comes up a little better. Uh, but I don't usually make videos like this, and I feel like a bit of a Bob Ross when it comes to Grasshopper and Rhino. But due to the response I'm getting, maybe I don't have to sit and teach so hard nose down on C# and GH Python nodes and just hit my window and see what comes up and see if I can build some interesting geometries and scripts for individuals. So I'll do that. Let's start a new file. We could save this one, I guess, as a 3DM file. I very rarely save. I don't think I've ever saved a 3DM file since I started Grasshopper and Rhino, but we'll do it now. We'll save a. We'll call it whatever. 001. Sorry, we'll call it 3DM, which it'll be a 3DM 001, and we'll save it there. And I'll build a GitHub file where you can get the GH file and you can get whatever you want. So let's just open it into this one. Will start in a perspective angle, and we'll take this down in scale. I have another file open behind me. We will get into rendering and doing some things after and picking materials. Hopefully make this interesting. But let's just, I don't know, maybe people are interested in how I kind of build things. So we'll go into here and we'll save this document as Grasshopper file 02. And somebody's calling me, so I might have to jump onto that for a second. So I'm going to hit pause. Let's just scrap this one and start fresh with a new script in Grasshopper. Now, what would I build? What do I think about? Well, I like offsetting surfaces, the normals. I like wheels. I like cupola carts, things like that. But let's just begin the same way that we did last time, trying to use these first 8 or 10 ribbon tool items here. We'll grab ourselves a point. Seems to be a good starting mark. And what can we do to that? We may want to move it many times in a direction. We could build a surface out of it. If we're going to do that, I might get into the GH Python node, what I've constructed. So if I jumped in here and took a look at surfaces, I think actually points is a random array of points, a 2D array of points. I'll just show you that little script, which is right there, which is an interesting little thing. Let's have a look into that. Basically, I'm running from 10 to 10, a range up to an integer, and I've written into the Python node. Pretty simple script, and I don't mean to make this so complicated for people, but you can cut and paste this and write out a pretty simple script for generating a surface. So let's see what we do with that. N's a number, an integer, so I'm just going to hit OK on that, and I'm going to set. I have a seed worked in there as well. And for those that don't do any Python programming, you can see that I imported Rhino geometry as RG and Rhino script syntax as RS, and I only use Rhino scripts, so I won't complicate things. I'll get rid of all this stuff so you don't have to worry about it. Import Rhino script syntax as RS. It's probably the most simple 2D array you can write. I did put a random in there, and I don't think, well, at least I thought I did. I had a seed working in there. It looks like I didn't actually produce a seed. So what I'm going to do is use my random and hit seed. And I'm going to actually hard code in a big SEED seed. And in doing so, I've got to come back to this item here and make that the variable capitalized. And I think I could actually see this differently. Not that it really even makes any sense to do so. So I'm just rambling on. I'm looking into my script. But let's grab an integer value here, 12, and put it into the seed and see what happens when we activate that node. And you can see what happens. I end up with this random 12-point item that jumps through this grid. And I do have a seed on it that I can jump in here and change. And I should be able to do that in all different directions. And I've got 12 items there. It looks like they're actually, yeah, I guess there's 12 in every case. So there's a bunch of points and they're all disordered and moving. But what I want to do is actually go back into my script and say, okay, we've got this grid of points and we're outputting the points, but I've chosen a random of those points. I don't actually get all the points. But I don't think that really matters. I'd be more interested in a random, let's just call this a lift. And I'm in here going a little deeper than I usually do, but since I have these little nodes that I offer, we'll call this a lift distance, and we will make another variable called lift, and it will be in the z direction. We'll give it a type hint float, which should be fun. And because we're dealing with small numbers, I'll just type in 12, and actually, no, I think I'll make my count to 10, take it back to a rational number, and I should be able to lift those points. Now, with any luck, if I run it, there you go, they are lifting. And because they're lifting and there's 12 points in the lift, I'm just playing around with my own custom nodes, and it might help if I grab my bifocals to show you that that's a Wickerson Studio GH node of a 2D point array. I still have that original point. I haven't decided what I'm going to do with it, but I'm actually thinking in here, like what could be done. Well, as soon as I see that everything's going in the same direction, I really enjoy the maths. One thing I liked about math was ranges and domains. I remember being quizzed as a young kid in public school. You know, what is a range, what is a domain, and writing your little guidelines to that. But I'm going to set my range up to that number, and my steps are going to be 12, but I always have to get into this step function when you divide a range and minus 1 from the integer value x. So that should allow me to pull a range like that for each of the numbers. But what am I doing? I'm not dealing in a list. I've got everyone doing that, and I'm not happy with that everyone's separate in that. And I don't know if I want it to process that way. That doesn't make me too happy, the division as to what's happening. It's not what I geometrically was hoping to do. So as we step through this and make more or less steps, let's say 7, and I jitter them around, I get all these different pillars, but they're not doing what I want. And thinking of them as points, I want to see how they're coming out. And by looking at fancy wires, you can look and say, oh, that's a list of lists, which actually isn't a bad thing. So I can take those lists of lists, and I can maybe do some, geometrically, I didn't really have a plan to what I wanted to do. But now I think I'm going to move those. And I think it would be nice to move those points in a transformation. And I'm going to move them in an x-axis. And I'm going to move them by a multiplier of, I'm going to throw in sine, but I'll need a multiplier on that. So I'm going to go to my maths and grab my little sine tool and throw that into a factor. Now that's not a what is the problem? It's having trouble, failed to collect data, and being that this sign is trying to do something to a value, and I haven't inputted that value yet. So let's just let's go to 0 to 2 pi, and see what happens when we start to bring that in. That should start to move things, obviously in one direction or another direction, but it's moving all of the points. So I'm going to take that and I'm going to actually graft it. I'm going to wait a second, see how many items just came out. I have 49 items behaving, and I'm going to see what happens. They're still doing the same thing. They look like they're behaving in a strange way, but I think what I'm going to have to do is take those points and move them, take all those points, and I'm going to have to deconstruct them and put them back together to make myself happy. So you start thinking geometrically. So let's grab those points. Let's go back up in the vector. Let's deconstruct the points. And before we put them together, this should be fun. Just dealing mathematically, and I'm just playing off my mind. I'm going to do that in the x direction. I'm going to do this one in the y direction, because I think this way. And I don't mean to confuse people, but it's how I think. And I'm going to grab this one, the math of cosine. And I'm going to have another number slider that plays between those ranges, what I consider pi, 0 to 2 pi. And I'm going to take this number value, which is very small, and this one is nice, and this one has another, is playing off that value as well, sine and cosine. What's the sine? What's the cos of that one? Why aren't you reading? There we go. I've got the different values. And I'm going to multiply. I'm going to actually go back into vectors and think of this. And if you don't think this way, well, then you're kind of in trouble. I deconstruct the vector. I don't want to take the vector. I don't want to amplify a vector. I actually want to go to the math and just do a multiplication. And I want x times x fed back into constructing a point. And that will go back into there. And then this one will go into this, this multiplication. And this is how I think. And this is how I visualize. And I think it's a great tool for moving things. So what I did was I just blasted this into a very strange pattern that if I was to take those points and they're structured in a certain way, if I want to visualize them, a nice thing to do is throw them through a curve. And you can see what you've gotten. You've gotten these pretty interesting curves. Taking a look at the data structure in a param viewer tells me if I have to go into, I'm going to simplify this, and it is not going to simplify because of these because it has two values here and here. I cannot flip the matrix to make it in another direction. But whenever I see that, because I like this tool, yeah, this is how I think. It's not that clear. It's not, especially when you're just trying to find something. Flip matrix isn't going to work. Bring it in there, it's not going to work because you can't flip this path with that indice amount. It's just not going to work. But you can go into here and go into your tree and grab yourself a path mapper, which is always nice. Grab that data and hit null. I do this quite a bit. Create null mapping. And then when I write it, I can take that data, and I like double clicking here, and I like to put the indices on it with a parentheses like that. And I like to write it into the equation. And what I may do is write it in here and shift out my B into the indices count. And let's see what happens there as I take it into here. And there you go. I've done something. And even though I'm not happy with the crazy count at the top, I moved from, this geometry to this geometry. And that may not excite you, but I do find the PathMapper a wonderful visualization tool. So I think what I'm going to do is not play around too much with it, have these two curves. And because there's still a list of lists and they're operating off of a path here, I think if I simplify, I'm not going to have any more luck. It wouldn't matter. I am going to loft between them geometrically to see what I have. And this could be fairly interesting if I take that data and this data and run it in. Get these kind of strange shapes. Don't work at the top. It's an awkward kind of table. But I've gotten 49 different lofts within here. And it's geometry that's just too complex. When I get that many going, I may want to go back down here and say 49 7 times 7. And I run my scripts as I test at a very low number. So I'm going to bring that up to 10. And I'm going to bring that way down to a 3 count. And it doesn't do anything in that direction because it doesn't spread out far enough. So let's bring it up to 4. 5 starts to jazz and do some interesting things. But as a ribbon tool or a ribbon table, I kind of like this. And I never would build furniture like this. I've never been wood in this direction. But I do like that. And now I'm going to take a look at what I actually have. What I have here is 36 different surfaces. I would believe that's what they would be, untrimmed surfaces. There are probably 36 of them there. So in grabbing them, you could list item and think of them differently. So going back in here and see what I geometrically made, you could have a list length to tell you what it is. And sometimes you do this and just grab this and just have an output to a param so you can see the number. And this is kind of clumsy to do it this way. It's not the best program, but it's how I sometimes think. And list length, I just need to know the loft. I might have to flatten this list to do it. And then I should be able to, one item there, okay. And let me just grab this and see what we have. We got 36 items, just so you're reminded of that. Now, 36 isn't going to come out and be a list item, an index number here. That's not good, even though that data coming in here is 36. I don't know if that's the final form that I want. So what I'd rather do is set up a number slider that kind of runs within that. And now I can go in and I can grab whatever iteration I want, depending on what it is, and I could output that as a surface. This is going to show me all of the surfaces, but if I go in here and flatten, it's going to show me every piece that I have to do to make that puzzle. And that's where you get into kind of a weird fabrication. And maybe you don't need all those, and you'll see that it'll roll through a few times. But as we go down, you can see that you get those little panels. And then if you decided you wanted to make something like that, which is fairly tricky, and sometimes the fold forms back on itself and twists and does these crazy things. But these geometries are actually nice little pieces of fabric if you want to stiffen it and make a mold too. I mean, and honestly, this is just kind of visualization to what you may make. And with any surface, I think you should probably take that surface and do a few things to it. So let's go into the surface and do let's do an evaluate surface. And we want to evaluate its normals. But what we'll probably want to do, actually, I'll probably want to take that surface and I will want to divide that surface. So going in the surfaces, I have to remember where all this stuff is. Utility, divide the surface. Let's divide it into a UV count. We get a bunch of points. Let's move those points. I guess we can put this on so it looks more exciting. Let's move those points in a direction. And we can move those, those initial points. We have this here. We want to move those guys out in the motion from their normals. But we probably want to, in those normal vectors, use an amplification. Or you could use a division or whatever you want. I'm going to put a little amplification of the vector on here, and I'm going to multiply that by only 0.11, and that way I can actually divide it. Let's see if I can pull that much closer back into where it was. So really close to where it is. And then with that, from here, I can create another surface from points. I believe that's divide surface from points. And as long as my UV count is the same as here, so it would be good to extract this. And you've got the count that's coming out as 10 probably. You put that back into U and you should be able to find yourself a surface. What happened? The U count is not valid for this, so let me just see if it's off by 1. Let me do 12. Throw it in the U count, see if it doesn't operate at 9, 10. Oh, I have to flatten my points. I'm such a fool. Whenever you do that, you have to flatten your points. So now I should be able to use that number of UV, and with any luck it will work. And of course it doesn't because I'm still off. So I'm going to go back and do my 12. I flatten my points. There it is. It's running at 11. So I would probably go in here and once again have my expression node of x minus 1. Now I'm watching the timer at 18 minutes. I haven't really gotten anywhere, but that was supposed to be x minus 1, and that should have worked fine. That's because 10 and 11 are x plus 1. So sometimes you have to play around a little bit with this. I'm not one to be that mathematically sound. It is interesting, and there we go. We've got an offset surface. We've got our original surface. What we can do is take our two surfaces, and I do this quite a bit. And you could call it a brep if you want, but I'm going to call it a surface. And a surface. Usually I deal in breps when I'm doing stuff in C and doing things in, that is our item. But I actually want the loft. And the reason I want to do that is these two objects, which are very nice, and this is just for one object, they can be debrepped. So let's debrep that. And let's debrep this one. And let's see what happens between those two. This surface and there's no way that's the surface I want. Hang on a second. This is all of them. This is all the items. I don't want all the items. I want the number 3 item. And that should be one item that needs to go to the surface. I went too far back. So you have this surface and you have this surface. They're slightly different. get this one and this one, because you've extruded them to normals. And with any luck, I should be able to take the edges of these curves, and bring them together. But in doing so, I sometimes have to graft this one and graft this one so they line up. And there you go. You've got what you have to make between these two surfaces so you have a nice solid. And because it twists, you get a funny piece of thing happening. But now what you have is actually, through merging all of these, if you wanted to, you could go back into sets. And I'm rambling on. I hope people find this interesting. It's just Wickerson in a nutshell, and believe me, he's a nut. What am I doing? Merge. Let's just grab that form. Let's grab that surface. Let's grab this middle surface, and let's grab this surface. And that's enough. That's a piece you'd have to make to slowly find a way to notch and bring this all together. Now, you got to do some weaving and some lap joining and fabrication and everything. But what's nice is if you look at this, this is an object. This is cool. These are the surfaces. This evaluate surface wasn't even used for our script. You can start editing things out. The points came in handy. I physically thought of moving. I've got a parameter here that can adjust with things. I can grab this data and bring it in here to be helpful. I can slide this one back up here for another parameter. This went nowhere, even though it's not nowhere. It just tells me my number slider where it should basically be. So I'm just going to leave that as data, and that's kind of understandable data. Let's bring these back to here. Let's bring our path mapper back, which we got hooked on, knowing we need some data thinking about that. And then I think let's just grab these two, pull them back here. This is how we clean up a file afterwards. I'm not doing anything fancy for sure. Let's grab these four, and let's slide them back. And I think we could grab these two, slide them down here, slide this one here, take these guys, move them here, gather them all up, put them all together, put them to the right, and with any luck, we can take this script and pop it in here. And what I have is my grouped, no, this is going to be the same problem as ever. Let me just zoom in. Oh, I love it when you do that. Okay, so we'll take this to orange to play. We will take this all to bake. Group that and say, okay, and that's just, instead of typing words, I just kind of think of colors. Let's take this and do color. Whoa, you little slippy slidey guy. For some reason, it's just a matter of the mouse. Come on. There we go. And now I should be able to grab all the junk in the middle, which is a nice little fun script, the Bob Ross style of Michael Wickerson. And there you go. You've got a script that we can go in, we can take off all the other jazz. You can look at it, which is funky. Now, why I wanted to show you that was if we took this and we made that preview off, and we're only looking at that surface, what we can do is we can roll through those 36 items. And of course, those 36 items are the index down here, and that's the index. So you probably will want to say, section index, and probably set that one aside from the others and say, okay, let's take a look at what's visible. Let's see, that section has to be made, that section. And you start to think of constructing plywoods or steel or ribbons of sheet metal. And you can actually fabricate a pretty crazy piece. Now, you don't have to build it into all these sections, but I think it's pretty nice that those are formally made for you. And what you can do is find the ones that are most interesting, like 40, and find the ones that you actually want to use, because you've got an awful lot of sections in here. And because I'm not showing them all, it might be nice, and this is a little cheat. You take your index off. You wouldn't do an index item. You take this whole thing and plug it into the loft, but then it's going to fault this system of extrusion. It's going to fault. So a nice thing to do for the index, and I'll show you this little technique I use all the time, and nobody taught me it. Plug in a gene pool, but set that gene pool to editing up to 36 numbers. 36, because that's how many there are. 36. And what you can do is have those 36 range from, what do we need? Actually, I think it's 36 items. We only need them to range from 0 to 1 because they'll either be on or off, I believe, and you don't need decimals. So now you've got, no, we're going to, I got that wrong. We're going to need 36 max. Watch this, 36. And this is nice. And then the gene count can just be, I don't know, I'm trying to think here. Okay, let's do a little scramble here. Boom. Now we've got 36 numbers coming out that are going to go in the gene pool. And I think what's going to be a problem is it's going to try and process each one of those separately. Yeah, it's going to crash my program. It only does one at a time. So now it's trying to loft all that data together. It just doesn't work. So what you have to do, and sadly, it's just the nature of doing it. You've got to have a number slider on here. Let's say 1 to, actually we could say 0 to 35. And now whatever section you want to do. What I was hoping is I could actually, I could do an animation that would show me all the sections that have to be made and extruded, which is nice from their normals. So you could just do this to display, let's just say 36 frames, and there you go. You'd have to build all that, and you made a little animation. The end ones are all kind of repetitive because they're extras, so they'd have to clean that up. But I do think that this one as data, obviously you want to make 0, 1, 2, 3, 4, 5, 6, probably up to 6 would be enough. And the only sad thing about that is you'd have to have a loop to do this. But what I'll do is I will take this data right here. I'm going to go this way. This way. Oh, yeah. Oh, there we go. Take all this. And I'm going to cut and paste 1, 2, and this is kind of a cheat, and this is not a good coding way to think about living. 3 and 4. And what I can do now, because I like those first numbers, is I could go in here to my list item, and I could add 1, 2, 3, 4, 5, and have 1 come down into this surface, 2 come down into this surface, and 3 come down to this surface. And this is not impressive to do stuff like this. 3, I think 1, 2, 3, and we'll grab 4 into this surface. And in doing so, I think we're okay to have these merge tools, as that's an object on top. Not that I'm very interested in 6. I actually just want to see 0. This one's 1. That one's 2. And I don't even think we need this because I think it defaults to that. So the only thing we have to do now is pull out this data, which I thought I copied, but I didn't. 1, 2, oh, let's get rid of that. Let's take this one and go cop 2, 3, 4. Take this one here, take this one here, take this one here, and take this one here. And because this is not something I'm trying to make super efficient and rack my brain around, let's take that loft, this loft, and this loft. Let's take this loft, and this loft. Let's take this one, and this one. Oh, Daniel Christa would be so angry with me for thinking this way. But when you don't know what you're doing and you're just trying to get things made, here's the objects. Let's take them over here, space them. And those are all the sections as they come together to make this insane table, at least the main bodies of it. And you can take them, and here's where we're going to end up baking. Yes. And actually, I probably, just for consistency's sake, I should probably go in here and hit bake group. And I should hit bake group. And I should hit bake bake group, and I should hit bake. This is so boring. This is Bob Ross. I should be talking like happy trees and making people happy with these videos. And bake happy trees. And now, leave Grasshopper behind. Come in here, grab your render, go into all views, tuck Grasshopper away with a little save file because you don't want to do it again. And you don't have to be embarrassed by your GH script. You just don't show it with anybody. Because in the end, it's how you ended up with geometries you ended up having. So what I have here is a strange line of surface. I'm going to come back into here. And now you do your magic in Rhino, and people are like, oh, you're so smart in how you came up with these incredible things. Gradient on. Let's stay pretty consistent with who I am. A nice dark blue. I'm not sure why my visuals are showing up. I need to leave that grasshopper behind. Why do I have this green? Maybe I baked it onto a layer. I don't remember. Ground plane is there. Skylights are on. Sunlight. I could take it off and put a little sun on there. Nope. We'll do skylights. I did bake them into different colors. And let's go into materials. Let's grab one object. And we can do it in layers. It wouldn't be bad to put our layers in layers, but I don't think I have to. Let's take this one. Let's think metallic. And let's choose I think they give you a choice of metals, which is kind of nice, but I don't think I need it. Polish, medium color. I thought they used to give you some nice things. I'll give it a hard blue. And we'll just put that one on assigned to object. We'll grab another one. And we will add another metallic hard orange. There we go. And that should be enough for the metallic, I think. Let's take that. And now let's grab this one over here, and let's grab this, and let's do a couple of glass, because we never, well, it should be metal or plywood, so let's do paint, as if we were painting. And let's just do an off-white. I mean, that's fine. Just an off-white, kind of a red. And let's bring that one in. Let's keep in mind how many objects we had. We can always take that to our visibility and get rid of it. Take that one to our visibility as we slowly get done this. And I've got this object. I'm going to take that into paint as well. And we'll take that to let's go down to purple. I don't mind purple. Just a dark purple like that. Kind of ugly. And that should be setting that to a purple surface. I thought we got it. Let's assign objects. Yeah, that should do it. And then that object should, as a group, go disappear. And that's another object which we will take to plastic. And just playing around here. A couple of colors. Dark, plastic, assigned objects, and hide that one. I don't know how many other objects are here. I am curious why everything's coming up in Grasshopper. So I'm going to take this to preview off, even though I thought I had that set. And I think we've gotten rid of everything, so let's bring it all out again. And there we go. Very interesting, strange line here. This one is an interesting surface that doesn't do anything. I don't know what it is, and I love the command what, and it's a curve, and I really don't want the curve because nothing came of it. Well, there's another one. That's very I guess those curves are coming off of the forms. So let me redo that one, and we'll just have to deal with them as lines and curves. Let's go into here because I mean, you're not really making anything. You're not really in real time doing these things. I'm going to take that one to render. I'm going to do zoom extends all. I know we're well over 34 minutes. I apologize for people that have stuck this out, but maybe they enjoy my voice. This one will go to pen and ink. Sorry, we'll go to pen. And this one will go to artistic. And obviously you have to ask yourself, like, is that at all possible to make? But as a concept drawing, and being an artist, I'm okay with it. I do think we've got something going on here that's kind of strange. I'm interested in what it looks like in a kind of, I I'm interested in those curves, like why that came about, and why my surfaces acted the way they did. There's only one way to really tell, and that's put it in the ray trace and wait it out and see what you get. And we get some strange forms here. So the colors are very awkward. Not sure if I want to even play around with this anymore. I'm not so satisfied with it. Let me take that one to visibility off, 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 and off, and off. Now that was odd. It was a very strange experience. And what it was, what exactly did we have? So as I take these and go to preview on, let me shrink that GHPython down. What exactly do we have there? Did I have an object rendered or let's say shaded? Did I have that extruded properly? Should I only be looking at the first one? It was okay initially, but I think I messed it up in some capacity from the extrusion from normals. And I think that's just what happened with this, is the data of I think that's probably my mistake. I feeds into all, that's exactly it. All right, I totally see my problem. And as you can tell, all these point back to I, and that's not the case. This one needs to point back to, yeah, I missed it. And that one needs to point back to here. And what's nice is when you're coming back from something, you can actually take it back into where you want it to go. Take that one back into 2. Take this one back into 3, I believe. Take this one back into 4. And that should solve our problem. So let's see it. Did it? Is 1 fixed? Let me see. There's the outer, there's the top, there's the side. Surface should have went into there. And surface should have went into there. And that should have been it. Do we have one? Okay. Take that off. There we go. That's our surface that should have worked. Now where's the loft? That should be it. That should be closed. That should be if I joined it. Once again here, same problem. This is kind of debugging in Grasshopper and why it's just so awesome. Until you do this, there's really no way to understand it. And I mean, just like building anything, you've got to tinker around, you've got to play. Long video, there they are. I'm much happier with the outcome. I'm going to take out all this stuff and say that was all faux pas poo-poo. And I may edit it out, but I also might leave it so people can see how this actually runs. Bake to a group, layer 1, bamf. Bake to a group, layer 2, oops, bamf. Bake to a group, layer 3, bamf. And bake, here we go. Bake to a group, layer 4, bamf. Very interesting how this is behaving. I like it. And bake to a group, layer 5, bamf. Very interesting. And with that said, I'm going to now leave Grasshopper and tuck it away and go back into here and say, through the render, what do I want? Let's grab one item and tuck it into here, assigned objects. Let's grab 2 items, assigned objects. Grab 3 items. And for those that stuck it out, they should be proud of me. Let's assign objects. And then this one. I thought I had a couple more colors on there. Come on. I must have more than 2. We'll just tuck in a metal. Bob Ross, late episode. And 5, tuck in a metal at color orange. And that's it. And there you go. There is my object. Designed, extruded, folded over, meticulous, destroyed. And let's do a little zoom extends all on it. And you've got a pretty interesting structure. I'll probably get rid of the technical view, go in here and show you that. And if anything, just squish down my ink and other drawing. So that's how I'm thinking. It is in connection with a Grasshopper script, so we can condense this all, bring it in here, show you the complexities of that. And you've got a way of extruding surfaces. And how do we generate all that? We generated that because of constructing a domain using a 2D array of tools, taking apart points, throwing in sine and cosine, a little bit of math, moving the object, playing with Path Mapper, lofting, getting everything set right. And I might edit that because it's a 41-minute video. Otherwise, I might just leave it on as total chaos. Good luck sticking through it. Thanks for watching.